And with that, let's get started. All right, couple things. First of all, Monday, I will be going through Chapter 8, Mole Problems for Mass with a Reaction. It's one thing you should know how to do, and I'll go through the practice problem set on Monday. Next Tuesday, I'll be doing my world famous review for the next test. And then on next Thursday, I will be giving test number 2. Excuse me. And test number 2 will be like test number 1, because I know a lot of you are working, and this course is supposed to be, and I have been keeping it truly asynchronous, even though I do have my Zoom-like meetings now. I do post them on YouTube, but next Thursday at about 8:30, 8:45, I'll send out the password for a PDF file that will be on Blackboard sometime Wednesday that you can download. And then you'll have until Friday morning, 9 a.m. to upload your answers to Blackboard. Don't forget that you should do it in a single PDF file. If you don't, I'll take off 5 points. It's in my instructions, so please do it right. Most of you have. And that's coming attractions. Also, speaking about coming attractions, by Sunday at the latest, hopefully Saturday, I will post information about test number 2. I've got to write it first, but it will cover all the chapters that are listed in the syllabus, whatever they are. I can't remember them now. I think 5, 6, 7, 8, and 9, but don't quote me on that. But look in the syllabus, it's right. And that's test number 2. And I'll talk more about it next week once I know how many pages, which I'll post in the next couple of days, and how many problems. But between now and Monday, practice. Do all the practice problems. This is the toughest test of the semester. But if you practice, it doesn't have to be. I've had summer classes with test number 2 and the averages were in the 90s. I've had classes where the test number 2, the average was 70. Hopefully you guys will be in the 90. All right. Oh, I know something I forgot to talk about. Last Thursday, I mentioned, I'll do this real quick, that I had a clogged, or just about clogged, bathroom sink. And I talked to you about the hair and grease remover from I get at Home Depot. And lo and behold, last Thursday, I followed the instructions. By the way, being a chemist who's worked with hazardous stuff, I had safety goggles on, which I have, heavy rubber gloves, and I had a lab coat on. If you don't have a lab coat, wear a long sleeve top, old one, just in case something happens. And I poured the amount they recommend down the drain. Being a chemist, and they warn you it might pop out or spit out at you. I'll teach you later in the semester. That's called an exotherm, giving off heat. But anyways, I put a plastic cup on it, a little weight, and that way, if it did, it wouldn't go everywhere. It didn't. Waited 24 hours, poured down some hot water carefully, the first one, then more. It's like it's brand new. Chemistry works, which is what that is. That's organic chemistry. All right, let's get to work. Today, I'd like to talk about the next lab. There's a Labster part and there's my part. You don't have to do, unless you want to have some fun, do the Labster part, but you do have to do mine. You'll hand it in. What does this deal with? Both deal with similar things. If you look at the formula of a molecule, how did the chemists find out? That's the formula. Well, before all the modern instrumentation we have, that's called spectrophotometry. It doesn't want to come out of my mouth right today. But anyway, spectroscopic means chemists use chemistry. And in the Labster, they have what's called gravimetric analysis, where you react something that has ions, and one of the ions reacts with what you're mixing with. to form a solid, you can separate it, weigh it, and you know how many grams that material is, you know the identity of that solid, and you can backtrack. There's an easier way, which I do in my lab, and that's react it with a chemical and weigh before and after. And remember that 1 mole equals the atomic weight of an atom or element. And today's lab, let's get to it. I'm going to do it. I haven't done it since yesterday. Thumbs up, people. See the lab? Thank you. I'm going to have to sell t-shirts. Thumbs up, people. But anyways, today's lab, number 7, is determination of the empirical formula of magnesium oxide. Now, magnesium oxide, the reason this is because it's a fun lab, and you'll see in a little while. Now, how do they determine, chemists determine key inorganic molecules? They use reactions and the mole concept to do this. In this lab, you're going to find the empirical formula, that means the simplest formula, of magnesium oxide. And here, I'm not going to give away the secret, but it's MgXOY. And this lab, you'll be reacting the oxygen here with magnesium to make this, which is this reaction 1. And this lab, you're going to find out what's X and what's I. Now, in life, not everything goes as you plan, as we're learning now, unfortunately. And air is made up of oxygen and nitrogen. And nitrogen will react with magnesium to form nitrous oxide. And you don't want that. Well, it turns out if you have in your reaction vessel, which we'll call a crucible, any of the magnesium nitride, it reacts with water to give you magnesium oxide plus ammonia at elevated temperatures and room temperatures. This is a gas and it goes away and you're left with this. So in this lab, you'll be using this, and it's important that you will use the concept 1 mole of an element equals the atomic weight in grams of that element. And that's how you're going to find out what is X and Y in magnesium oxide. By the way, one interesting use of magnesium oxide, if you go to your local drugstore, I know Walgreens sells it and other places, you can buy where they have all the vitamins and supplements. They have one called magnesium oxide. It's a capsule with magnesium oxide in a binder, and you take it. And what do you take it for? It's a very mild laxative. A laxative is something that makes you go to the bathroom when you can't. And this is one use of it. There are other uses, but I thought you'd learn about stuff in your everyday life, what it is stuff used for. Now, the procedure, if you were in the lab, and this is a fun lab, and you'll see why in a second, is a crucible and a crucible cover. To clean it, you heat it over a Bunsen burner for 5 minutes, then you let it cool. And then you record the weight weigh it and record the weight of the crucible and crucible cover. Then you add a certain amount of magnesium. I think it's about 3 or 4 centimeters of magnesium metal. It's in a ribbon. Some schools use a powder, and it's about 0.2 to 0.5 grams. And then you weigh that, the crucible cover, and the magnesium. And from that, and I'll show you in a second, you can find out how much magnesium you have. Next, you heat the magnesium metal in the crucible with the crucible cover partly off over a Bunsen burner. This is the fun part. Remember, Dr. White is a pyromaniac at heart, loved to burn things. This is an exciting lab to do. And you heat it, and if you see a white flame, you cover the crucible for about 15 seconds with the cover, what you're doing is cutting out the oxygen so it doesn't burn too fast, because you'll also see white smoke when that white flame is going on, which means you're losing your magnesium oxide, which is white powder. When all the magnesium is a white powder, you remove the Bunsen burner, let it cool for about 2 minutes, and carefully add 15 drops or so of water, and that's to react the magnesium nitride. And you heat it again for 5 minutes, and then you cool the crucible, cover magnesium oxide. You weigh all those in number 7, and then after you're done, you put the magnesium oxide in a waste bottle, rinse out the crucible and crucible cover, and dry them and put them back where you got them. Hang in there, I'm jumping around. Thumbs up, people. Do you see YouTube? Thank you.
In this lab, you will experimentally determine the empirical formula for magnesium oxide. You will do this by combusting magnesium in an oxygen-rich environment.
Oh, let's watch the whole thing.
To begin, you will need to determine the mass of a crucible and its lid. Make sure they are both clean and dry before you weigh them. Once you've recorded the weight of the crucible and the lid, add in the magnesium ribbon and record the combined weight. The weight of the ribbon should be about 0.5 to 0.75 grams. Do not wrap the magnesium ribbon too tightly. Air needs to get in for the reaction to take place. When lighting a Bunsen burner, ensure that anything flammable such as hair or clothing is well out of the way. Turn on the gas flow and then bring a lit match or lighter towards the end of the Bunsen burner and it should ignite. In order for this reaction to proceed properly, you need to make sure that the Bunsen burner is close enough to the crucible to heat it well. The high temperature will cause the magnesium to ignite, but first the crucible will begin to glow with the heat. Raising the lid of the crucible will allow oxygen from the air to enter the crucible. This will ignite the magnesium, causing the formation of magnesium oxide. Do not look directly at burning magnesium. The intense light can damage your eyes. During this reaction, you will want to ensure that oxygen gets in for the reaction to take place. You can either do this by tilting the lid off the crucible slightly to allow oxygen flow, or raising and lowering the lid periodically. Be sure not to let the reaction smoke too much. Any smoke coming out of the system is actually a loss of product. Allow the reaction to proceed, periodically checking on it to see whether or not ignition occurs when the lid is raised. When ignition finally ceases, you know that the reaction is done. At the moment, you can see this is still glowing hot, but no ignition is taking place, so we know that the reaction is done. You can turn off the Bunsen burner and leave the crucible to cool. Allow it to cool completely before proceeding with the next step. Using a medicine dropper, add a small volume of water to turn the solid in the bottom of the crucible into a thick paste. You'll do this by stirring it up with a glass stirring rod. Ensure that all the material remains within the crucible, so wipe off the stirring rod on the edge of the crucible before you complete this step. Return the crucible to the Bunsen burner and heat it once again. This will complete the formation of the magnesium oxide. This process will take several minutes, but you can check on it periodically, and once it is all light gray color, the reaction is complete. After the drying process, allow the crucible to cool before weighing it. Make sure that it is cooled completely before you proceed with this step. Obtain and record the final mass of the crucible and the solids within it. Finally, clean and scrub the crucible to remove any of the solids to ensure that it is completely clean before returning it.
Hello, everyone. I'm coming directly to you for ask a quick favor.
Hold on.
Will you add your name today to join our team?
I would, but not in a class. All right, hold on before we continue on. First of all, if you saw the video, which I hope you all did you all hear it too? Thumbs up, people? Do you hear it? Thank you. All right, first of all, beginning of the, not the beginning, but into the video, the guy lighting the Bunsen burner made a big mistake. You never open the gas before you light your lighter or have a flame. You light the flame, hold it there, and then open the gas. That's number one mistake, and that even though it's quite a good video, which is why I picked it. The other thing which we have never done, and I've taught this lab, well, for many times, after you put the water in, you don't have to stir it because you're going to wind up with product on your stirring rod and that'll mess up your results. We just put the water in, heat it up, it works fine. But everything else is correct. Did you notice the balance that was Mettler? Mettler is probably the best company that makes balances in the world. I've used Mettlers for, well, long time. All right, let's get back to the lab. Now, because you're not working in the lab, Dr. White has given you the data. And if you notice the data, you have the initial weight of the crucible and crucible covers here, crucible cover, and magnesium here. If you subtract 1 minus 2, you get the weight of the magnesium, which I'm calling 3. All right, afterward, you'll weigh the crucible cover, and now the magnesium oxide, and you'll get this weight, number 4. You'll also, from previous, you don't have to do it again, from you had number 2, the weight of the empty crucible and crucible cover from your initial data. If you subtract 4 minus 2, you now have the weight of the magnesium oxide. Now, in calculations, first one, and this is important, we're not dealing with oxygen gas, O2, we're dealing with oxygen atoms. Oh, really? Oh no, I'm getting O, hung up on O. It's Dr. White's being silly Thursday. But anyways, weight of oxygen atoms is number 5 minus number 3 up here. And now you know from this experiment how much magnesium you started with and used, how much oxygen was added to the magnesium, that's oxygen atoms. And you should note, it's important to know 1 mole of an element equals the weight of the element in grams divided by the atomic weight in grams. And this is based on 1 mole of an element equals the molecular weight, atomic weight of the element. So to calculate the moles of magnesium, you have to do this. Use equation 1. What you put in here is the weight of the magnesium you figured up above, and that would be number 3, and then divide it by the atomic weight of magnesium. And you can find the atomic weight, just to remind you. You go to your periodic table, you see underneath the symbol magnesium, round that off to the number at the bottom, 24.305, to 3 significant figures for your calculations. Nope, you rounded it off wrong. I'll let you figure it out later on if you can't. It's 23.305. Round that off, try again to 3 significant figures. All right, let's continue on. And that way you'll know the moles of magnesium. Now, in number 3 calculation, you want to calculate the moles of oxygen atom. Notice there's no 2 there. And therefore, you have up here, number 5, the grams of oxygen atoms. And therefore, moles of oxygen divided, you take the weight of the oxygen, number 5, and divide it by the atomic weight of oxygen, not oxygen gas. It's a common mistake students make, oxygen atom. And you can look in the periodic table for that number. Now in 2 and 3, you're going to have 2 numbers. One of these is going to be smaller than the other. Trust me, that will. And then we go to number 4. Number 4 is you take your answer from calculation 2, moles of magnesium, and divide it by the smaller number in calculation 2 or 3. And you round that off to the nearest whole number, because you can't have fractions of molecules. And this will be the X in MgXOY, magnesium oxide. Next, you'll go to number 5 calculation, and you'll take the moles of oxygen. Again, this is atoms, your answer in calculation 3, and divide it by the smaller number in either 2 or 3, and round that off to the nearest whole number. And this is Y in magnesium oxide. And then number 6, I'm asking you to write the formula, MgXOY, where you put actual numbers for what is X and what is Y. And then I threw in a couple questions for you to have fun with, and you'll upload this by next Tuesday, and that's the lab. Any questions? Remember, if you have questions, you can always ask after class. Come to my office hours on Monday, Wednesday night, which a number of you did last night, or email me. I check my email twice a day, in the morning and early evening. Morning, today I checked it, was about 6 a.m. When I say morning, I mean morning. All right, any questions about the lab? Ooh, that reminds me. This is a fun lab. See how the white flame when they took off the cover? Well, first, it's happened more than once. I've had students forget to put the cover on. All of a sudden they see this white light and flame. It's very hot and it is very bright. And they get scared and start screaming, help, help. And I say, relax. And I come over, take the tongs, put the cover back on. That eliminates oxygen, which slows it down. You learned about limiting reactants. That's what we're doing. And then you can open it up again and control the oxygen. Why you don't want any that flame, because smoke coming out is your magnesium oxide, and that will throw it out. Now, there's a very dangerous part of the lab, which you're not going to experience, but when I teach it, I make sure it doesn't happen. But about 8, 9 years ago at COD, student didn't listen to me, unfortunately. The crucible and the cover gets well above 1,000 degrees Fahrenheit. And once in a while, students who are not used to using tongs to pick up the lid and put it down, it will drop and fall to the bench top. And when you do it in the lab, you do it in duplicate, you do 2 of those, there's plenty of time to do that. And I tell students, if the lid falls, don't try and catch it with your hand, because it's hot and it's going to burn your hand. Well, during a lab, if you were in the lab with me, I'd be walking around saying, don't touch the lid. If it falls, let it hit the ground. It's not that expensive. And you got plenty of time to repeat the experiment. Well, I had one student and she didn't listen. She went like this and immediately like that, but she had a 2nd-degree burn here, which I felt sorry for her. We got her medical attention. And about a day or 2 later, I got a call from her mother, who was a nurse. And her mother was extremely upset with me and was screaming at me at the phone. And I was patient because I could understand why she was upset. Her daughter had a really bad burn on her hand that was taken care of, but still it was there. And after she got through yelling at me, I said, could you do one thing? She said, what? And I said, ask your daughter, what was I saying during the lab? She came back to the phone and apologized to me. And I said, I'm sorry that happened to your daughter, but there's only so much I can do. And That's the only time that's ever happened where somebody burned themselves like that, even though it could happen. But it's a fun lab. If you want, go back and look at the video. I did twice because it's neat to watch magnesium burn. How many of you have ever seen the movies where it's a battlefield at night, like from World War II, and some soldier shoots this, looks like a gun, and it goes up in the air. All of a sudden, it lights up the whole battlefield. What it is on a little parachute, there's magnesium that is ignited, a big piece of it, and it's so bright, it lights up the whole battlefield. And that's another use for magnesium metal. All right, any questions about the lab? Going once? Going twice? Let's move on. Wait, I see something. All right. One of your students, colleagues said for 2 and 3, you got the same number for MG and O. Use either one if it's the same, okay? Pick number 2 or pick number 3. If it's the same, it doesn't matter. It will work out. I did the calculations. If you go to 4 or 5 significant figures, I think there's a slight difference.
Dr. White, I have a question too.
Yes.
About the molecular weight of magnesium. So here in the table.
Not molecular weight, atomic weight.
Atomic weight, I'm sorry.
Yeah, sorry.
It is 24.3050.
Right. How do you round that off? Can you see the periodic table on the screen right
Yes.
now? All right.
Yes.
Let's do 1 because it's good practice for test number 2, because on test number 2, it'll say, please round off I use all atomic numbers to 3 significant figures. And if you get the wrong answer, because you didn't do that, I'll take off a point.
Yeah.
And let's look, how do you round off 24.305 to 3 significant figures? Keep
Yes.
the 2, keep the 4, keep the 3. Those are your 3 significant figures. What number do you use to round off? 0. Is that 4 or less or 5 or higher? Time's up.
Yeah.
Hopefully you pick 4 or high or less. Therefore, you drop the 0, drop the 5, and the correct answer here is 24.3.
Okay, so we need to round up the 4th number, not the 3rd. Okay, now I got it.
Well, that's how you round off, period. If it's
I round out the number 3. That's why I did the mistake. So
right, because then you were rounding it off to 2 significant figures, which is what I'm asking. Let's try for everybody else. Let's try one more.
Okay.
Don't say the answer because I want everybody to try. Let's look at carbon. What would be the atomic weight of carbon, 12.011, to 3 significant figures? I'll give you 5 seconds. 1, 2, 3, 4, 4.2, 4.6, 4.65. I've got a slow stop clock. Time's up. And we look at this. Keep the 1, keep the 12, keep the 2, keep the 0. Those are my 3 significant figures. I use the 1 to round off. Is that 4 or less or 5 or higher? It's 4 or less, so I drop that 1, and the 3 significant figures. Carbon, which you don't need for this lab, but you might for the test, is 12.0. You got it? Everybody okay? And now you know. And it's always good to ask questions. And by the way, Suela, thank you for your question. As you know, in my universe, there's no such thing as a dumb question because all questions are good questions. By the way, Dr. White really practices that. And I really believe it too, which is a good thing. All right. Next, I promised today, so I better keep my promise. Dr. White does that. I'm going to go over some of the problems in the balanced chemical equations problem set. Before I do that, let me tell you that if you look in Blackboard, the balanced chemical equation lab, I have graded, and you guys did really good. Thank you. You should go like that because you all did a good job. And I'll put the answers on Monday. I'll put it up, but I will take it off the video because I don't want those floating around the internet. But I realize two things that I didn't teach you, so I better teach it to you now. Let's first look at the balanced chemical equation. How do you do it? And let's look at sodium plus chlorine makes sodium chloride. And let me jump to my whiteboard. Get my pen out. Every time I see sodium chloride, table salt, I think about me in a restaurant saying, could you please pass the NaCl, NaCl. But anyways, balance it real quick. I have 2 chlorine. I have now 2 chlorine. Remember, you can't change this, the formula, but you can change the coefficient, the number in front. And this side I won't, but this side I did. Now I have 2 sodium. And to get 2 sodium on this side, I do that. 2 sodium, 2 sodium, 2 chlorine, 2 chlorine. Now, what I didn't teach you, and pay attention, I did not take this off on the lab, but I will on the test. You could have also had something like this. And notice 4 sodium, 4 sodium, 4 chlorine, 4 chlorine. So technically this is balanced. However, this is, hold on, let me go Technicolor on you. That's supposed to be an N, hold on. It's wrong. Why? Because the convention for balancing equations are, if you can divide all the coefficients by one number and still get whole numbers, you should. You shouldn't have multiples. See how this is a multiple of that, which is how I came up with it. This is the correct balanced equation. This would be wrong. And that's important when you're doing further calculations. So if you can divide all the coefficients by the same number and get whole numbers, then you should, because it should have the simplest ratios here. And that's an important thing you should know. And a couple of you did that. And I didn't mark it wrong in this lab because I wasn't sure, did I discuss this? Again, when you have the coefficients that you can divide by one number, and if I divide this by 2, I get 2. If I divide this by 2, I get 1. If I divide this by 2, I get 2. These are all whole numbers. Then you get the correct balanced equation. That's one thing. Another thing that most of you got wrong, and if you got everything right, you got 11. If you got 1 or 2 wrong, I give you 10. 3 or 4 wrong. I don't think anybody did this, but if you did, I'd give you 9. I don't grade that hard for this lab. But number 2 on the first problem set was add the coefficients. A lot of you put down 8. The answer is 9. And I'll ask you for this one. Add the coefficients. Don't put out the answer on chat yet. What's the sum of all the coefficients on this reaction on top? Time's up. The answer is 5. A lot of you probably put down 4 because you forgot when there's no number, the coefficient is 1. So it'd be 2 plus 1 plus 2, which is why the sum of the coefficients is 5. The reason why I put that in there and had that question was to remind you that when you're doing certain calculations and you have to know the coefficients, that when there's nothing there, it's implied it's 1. Now, if we look at number 2, now hold on while I write it down. This is what I call even odd case. And notice here I have 2 oxygen, here I have 3. The coefficient is always a whole number. There's no way I can multiply 2 times a whole number and get 3. There's no way I can multiply a whole number times 3 and get 2. So what do? I find a number they're both divide into and get a whole number. And that way you can multiply it by those numbers. And the easiest way is take this number of the even, take this as the odd, multiply them together, you get 6. 2 goes into 6 3 times. 3 goes into 6 2 times. And now I can do the rest of the balance equation. This side has 6 oxygen, better. This side has 6 oxygen. Notice 2 times 2 as 4 aluminum. And how do I get 4 aluminum? I do that. And that's even odd. And I don't know if you call it a trick or methodology, but it's helped Dr. White. If we look at number 6, remember my advice, always do hydrogen, oxygen last. Now here we have 5 carbons. Before you put the number there, you have 1. How do I get to 5? Put a 5 there. Now all I have left is hydrogen and oxygen. Here I have 12, excuse me, hydrogen. How do I get 12 on here? Because I only have 2 before I put the number 6. I put 6, and that's 12. Now I have 2 oxygen here, but I have 5 times 2 is 10, plus 6 times 1 is 6. 10 plus 6 is 16. How do I get 16? 2 into 16 is 8. Again, you do the hydrogen, oxygen last. And I think most of you got that from the lab. The lab was meant to give you a lot of exercise doing this. And here's another example. 1 aluminum, 2, put the 2 there. 1 sulfur, 3. Remember, when it's inside a bracket, it's the number inside times the number outside. So I have 3 sulfur, I put a 3 here, and now all you have left are hydrogen and oxygen. Here I have 2, so I have 3 here times 2, 6. Put the 3 there. Here I have 4 times 3, 12. 3 times 4, 12. I'm done. I'm not going to do any more of these because everybody did real well on the problem set. Now, time out for a tea break. Hang in there. Oh, that's good. Wild blueberry, one of my favorites. Earlier today, I had my vanilla almond. But anyways, listen carefully. Don't tell anybody, but on test number 2, I will have either 3 or 4. You've got to balance the chemical equations. At 3 points apiece, that's either 9 or 12 points. This is an important skill. I think most of you got it. Remember the key things. 1, you have the same number of atoms of each type on both sides. 2, remember the even odd I just showed you. 3, pro tip from the pro, me, Dr. White, and that is leave hydrogen, oxygen last. And that's how you balance a chemical equation. And this weekend, if you happen to go on any party, I hope not, keep your social distancing. You notice Illinois has done quite well compared to places like Texas, Florida, because we've got a good governor and we have good citizens who wore masks and still do, and also keep their social distancing. In fact, I happened to look yesterday afternoon out my window, front window. I saw a father pushing, helping his son on a bicycle, and they both had masks on, which made me feel good. 1, see people out and life is going on, and 2, see they were both protected. I wear masks. I have both. Luckily, I have a friend of mine in Indiana, and when he shut down his company, he saved a bunch of N95 3M masks, and he sent me 2. And when it first started getting bad, I realized I should have some. And I also ordered a bunch of KN95 from a good company in China, which has since been sold out. But anyways, let's move on. Oh my God, time flies when you're having fun with magnesium and other stuff. All right, yesterday I was talking about gases, and we were talking about Boyles Law. And if you notice, I put something here that I hand wrote yesterday. And Boyles Law, don't worry about this stuff. I'll never ask you what Boyles Law is. And Boyles Law is P1 times V1 equals P2 times V2. And let me just do a quick check because I haven't done it much today. Thumbs up, people. Can you see it? Excellent. You know what I haven't done all day today? It's time for your daily dose of, I love it, which is why I have about 4 of those throughout my house. Whenever I need a pick me up, they're there. All right. Boyles Law is P1 times V1 equals P2 times V2. P1 is your initial pressure. V1 is your initial volume, what you start with. P2 is your final pressure, and V2 is your final volume. Now, when you do Boyles Law or use it, the temperature is kept constant. And note, pressure and volume can be in any units. Not all gas laws are like that, but Boyles Law, it is. So let's have some fun with Boyles Law. And remember, this is for test number 3 material now. I think I spelled balloon right. If not, you correct me later on. All right, time for Dr. White to decode what I just wrote. And when I found a board and a COD, you'd have to wait while I wrote this down. If a balloon has a pressure of 851 torr and a volume of 4.32 L is liters volume, then what happens? What is the volume of the balloon? I think there's two L's there. If the pressure is reduced to 632 torr. So let's take a look at this. What are we being asked to find? What's the volume of the balloon after you do something? And that's called V2. Next, what are we given? We're given initial pressure. P1 equals 851 torr. Torr is a measure of pressure. We're given initial volume. That's V1. V1 is the initial volume. In this case, it's 4.32 liters. And finally, we're given when the pressure is reduced to this amount. That's the final pressure, P2. Now, if we look at this right here, the only thing we have to work with is volume and pressure. And immediately that should tell you Boyles Law. And on test, you'll be given this important information. P1 times V1 equals P2 times V2. Now, everybody take a deep breath. Let it out. Take a deep breath. Let it out. You're all nice and relaxed. We're going to do some algebra. Take a deep breath. Let it out. Forget about my phone. It'll ring 2 more times and my answer machine will get it. Notice Dr. White has a very soft ringer. Stop. Thank you. Sorry about that. See, the phones even listen to me. I'm that powerful. But anyways, we're going to do some algebra. Relax. Take a deep breath. I'm going to show you how to do it. All right. Now, if we look at our equation over here, what do we need to solve for? And the answer is V2. So in order to solve for that, I would like it alone on one side. How do I get it alone on one side? Well, remember, anything divided by itself equals the number 1. So if I want it alone on one side, and I'll rewrite this, I want to get rid of P2. I'm going to divide by that because anything divided by itself becomes the number 1 and it's gone. But whatever you do to one side, you have to do to the other. And now you don't have to do this, but Dr. White likes to, and good habits I don't change. I'm going to rewrite this right here. Notice this cancels out. Therefore, this is V2 equals P1 times V1 over P2. Let's go through what I did. I figured out what was I trying to solve for. And I look at this equation. If I want to solve for this, I need it alone on one side. Well, I got to get rid of this. How do I get rid of it? Anything divided by itself becomes the number 1. Hold on. Somebody already got the answer. Hang in there. I'll be there. And therefore, I divide this side by P2 to get rid of P2 because I want V2 alone. But whatever I do to one side, I have to do the other. And I did that. Now, for me, I like to rewrite it. You don't have to. All this is after P2 cancels out because of this, V2 equals P1 times V1 over P2. Now, the nice thing is, once you've taken the time to do this, all I have to do is fill in the blanks. P1 is 851 torr. V1 is 4.32 liters. And P2 is 632 torr. Now, I'm going to use I bet you never thought I'd say it, but my good friend, my good buddy, unit analysis. Yep, I'm going to do that. I did. And I look at, notice up here I have torr, and here I have torr. Anything divided by itself equals number 1. So torr cancels out. What units am I left with? Liters. That's the volume. I'm trying to find volume. I'm on the right track. So now it's time for me to get my calculator out. And by the way, I didn't have it here. Nope, that's right. Hang in there while I open up my spreadsheet, which I should have had open. And if I hit enter, this is the number I get. Now, let's see, I put in everything, 851, 4.32 divided by 632. Now, if we look at the numbers up here, 3 significant, 3, 3, my answer should be 3. I'm going to give you 3 seconds to round that off to 3 significant figures. Time's up. Keep the 5. Keep the 8. keep the 1. Those are my 3 significant figures. I use the 6 to round off. That's 5 or higher. I'm going to drop everything, increase the 1 to 2, and my answer would be 5.82 liters. And if I go back to my whiteboard, so if you look what happens when you decrease the pressure, the volume increases, and that's Boyles Law, and that helps you. Now, as I look at the clock, we're sort of running out of time, so hold on, I'm gonna sneeze. Nope, I think I stifled it. But anyways, no, everybody, I hope you have your mask on. No, it's through the safety. I see we don't have enough time to do another problem, so I'm going to do something very rare. Don't tell the dean. Oh wait, this is asynchronous, so I can go as long as I want. But I'm going to let you out a whole 90 seconds early. It's one of the rare times I'll do that. With that, let me remind you, I'll probably spend another minute reminding you, do the practice problems. Test number 2 is coming up. Don't forget to do the lab on magnesium oxide and upload it by next Tuesday. Check Blackboard. I put in the last lab. I'm pretty much caught up. If you see blanks, no score, that means I had a problem or you reading your lab or you never uploaded it. I'm going to try and reach out to some of you, or I had problems reading it. Those who didn't do it, or if you didn't go on Labster, you didn't get points, even if you have to log on and try something, but study for test number 2. And with that, be safe, enjoy the weather. I'm going to do battle with Mother Nature this weekend. The rain lets up. In other words, mow my lawn and other stuff. And with that, I'll say bye, gehen gesund, be healthy, have a great next couple of days and weekend, and I'll see you on Monday. Remember, if you have any questions, feel free to email me, and also go to my office hours on Monday and Tuesday. It's not Tuesday, Monday and Wednesday. Bye.